All right, thanks everyone for coming. My name is Jens Pillgram Larsen. I'm an engineering manager in the tools team at LinkedIn. The tools team is, we're the team that's responsible for building all of the internal tools and supporting both the engineering and operations organizations at LinkedIn when they do things. And we are the team that's responsible for the Gradle-based build infrastructure, which is probably not a surprise given that we are at the Gradle Summit. So today I'm going to talk about a little bit of the history and evolution of how we build code and have built code at LinkedIn. It's important to understand that evolution to understand where we are today. And then talk a little bit about how do we do product development. So there's obvious things in terms of how Gradle is structured versus how we structure our code and how we collect our code together into what we call products at LinkedIn. And then I'm specifically going to go a little bit into our Gradle-based infrastructure. And that's something like Stepan probably knows more about than I do. So if there are questions, I can try to answer that. But if you want a really deep dive into the nitty-gritty stuff, I'll have to defer that. And then just a couple of slides about what's coming down the pipe and what would we like to do in the future. So building code at LinkedIn. So building code at LinkedIn, I would say, if you're looking for a way as like this is how you should do things, you probably don't want to look at too hard at how we're doing things. LinkedIn is a fairly old enterprise software company at this point. It was founded in 2002, 2003. And the best practices, continuous delivery, continuous integration, things like that, have really evolved a lot over the time that LinkedIn has been in existence. So when they first got together, there were 7 people in Reid Hoffman's living room, and they started building code. And the natural thing to do is you take one repository and you put all your code into that one repository and everybody works on that. And it was called network because, hey, what is LinkedIn, right? It's a network. So it's very homogeneous at the time. It's a single code base. And then everything inside it was built from source. So you could declare a dependency on everything and anything. And there was little to no management in terms of making sure there were no cycles, the code was architected and structured in a specific way. Ant was the build framework. You had Java and Spring as the main building blocks. Then you had your JavaScript, HTML, JSP, and CSS, etc. on your front ends to build your UIs. And then you deployed these wars into Jetty or Tomcat and ran them that way. So very standard boilerplate stuff. And that went along for quite some time, about 5 or 6 years. And then it hit the hockey stick and hit it hard in about 2008, 2009. And we've been on that hockey stick ever since. And at that point, if there's anybody here who's been at a hypergrowth company, especially one that's been in hypergrowth for a long time, everything just goes out the window. Because everybody or half of your developers have been there for less than a year. So maintaining a culture or process, there's nobody, the fabric of your company no longer knows or has a consistent way of doing things. Because half of them are new. And the other half have had various amounts of tenure. So being in an established linear growth company versus one that's been in hypergrowth for a long time is just different. So our number of developers, our number of programming languages, frameworks, build tools, everything went exponential at the same time. So we found ourselves going from this nice little box where things were homogeneous. And then over time, it turned into this. And as technologies grew, we acquired new companies, we acquired new technologies. Everything just ballooned into this heterogeneous stack of things. And this, by the way, this is what I could think of in like 5 minutes off the top of my head. There are many, many more obvious examples of things that we use today that aren't on this slide. I could probably make it a lot more messy if I wanted to. Now, I want to say hypergrowth is probably the most fun thing to do in your professional lives. If you can get to a point where you're at a company that's growing exponentially, there's probably nothing better than that. But at the same time, if you're trying to do build automation, if you're trying to do things better, faster, if you're trying to migrate your organization from doing something bad to doing something good or just improving it, it's probably the hardest thing to do. Because you're always answering. You come to work every day and you answer the same question. What is this thing? What does it do? How do I use it? And it just sucks your time and energy like nothing else. So we had all these acquisitions. We started, so we went IPO 2011, had a lot more money. We started buying companies, and they all do things a different way. And as I said, we also had all of these people who had been at the company. Half of the developers had been at the company for less than a year. They also had their way of doing things. They came from other companies, a lot of people from Yahoo, Ariba, et cetera, and they had a specific way that they develop and architected code. So at a little bit over about 2 years into hypergrowth, there was just pain. There was just a massive, massive amounts of pain. Like we can't keep going this way. So we sat down and we said, what does it take to get out of pain and onto some kind of sensible code management structure? These things are, I'm sure to you guys, you're all at an automation and Gradle conference. Hopefully all of these things are like, yeah, of course you have to do this. This was not obvious at the time to us. You need very sensible code and dependency management. You cannot let things descend into chaos. That's both at the source code API level and also at the service API layer. So we're a service-oriented architecture. We run different services. They talk to each other. You need sensible ways to declare service APIs and use those service APIs. You need to maintain backwards compatibility in both your source APIs and your service APIs most of the time. Or when you break it, you need to know that you broke it. And you need to use version dependencies. Again, whether it's runtime or compile time, they have to be versioned. You have to be able to reason about what are my dependencies, how are they used. In order to scale, you must go faster. It goes hand in hand. And it's not one of those things where you say, today we're going to be slow, tomorrow we're going to be fast. It's a culture change of iterative improvements. So I think Stepan did a good job this morning talking about how that works at Gradleware. So we're trying to do the same thing at LinkedIn, and we have been trying for the past 2 years. Every day, go a little bit faster. Every time we change or refactor something, do it faster. Whether it's static content or SaaS compilation, whether it's moving to these different code repositories, make things faster, and that allows you naturally to scale. And then you have to start isolating things. When you're a small company, you can put everything in one place and work on that one place. When you're 1,000 developers, there's no way you can put everything in one place. Even if it worked from a technology perspective, you don't want to do that. You want to divide and conquer. You need to isolate. And this concept of code isolation really became the thing that we had to look at. If my code depends on your code, then sure, failures in your code affects me. But if my code has nothing to do with your code, then if you break the unit tests, why should I be prevented from releasing? It sounds so simple, right? But when you have a single code base with no dependency management, you don't know what depends on each other. So something breaks, everybody stops. The world stops. It's very, very painful. The other thing is, as you become a bigger company, there are different, basically, methodologies. There are different stages of code maturity. So you'll have very, very fast-moving experimental projects that may or may not pan out, and a lot of them just fizzle and die. Then you have very, very stable, long-running projects and products that are deployed, that are making money for the company, and that change very infrequently, and everything in between. So you need to be able to isolate these different pieces of the system from each other. So that was one thing. The other thing was, well, we need to achieve sanity in this existing code base that we have. There's no way that we can continue doing what we're doing. So at the time, we were following kind of the CVS subversion model of development, which is you cut a feature branch, you go and you develop your feature, and at some point in time, you pick a calendar date, and you try to merge everything into a release branch to get to that calendar date. And then you spend all of your time. First of all, your feature branches may or may not be stable in their own right. When you merge, for sure, the release branch is going to be unstable for a while. It is absolutely impossible to achieve continuous delivery with such a system. It does not work. So now you can still have branches. I mean, Git has taught us that we can definitely have branching. You can have a sane branching model. But one way of doing really fast continuous delivery is just having a single branch, just using a single branch. And that's what we did. So we put everything, all development happens on trunk, on one branch. And every time that branch is stable, which hopefully is most of the time, but in practice maybe not so much, we release and we deploy. Right now, we have kind of an artificial constraint due to business reasons that we only deploy to production 3 times a day. But obviously, the goal is to get away from that. So every time something is stable, every time something is ready, every time software has been certified, it gets deployed to production and goes out to the site. And this, at the time when this was started, I think it was, what, every 2 months? Is that right?
No, 2 weeks.
2 weeks, OK.
Hovered around the 2 week.
Hovered around the 2-week margin. That's when we could deploy. And as I said, right now it's 3 times a day in production. It's continuous in pre-production. So every time you make a code change, no matter how small, it gets deployed, it gets certified. And then it's one button push to put it out to production. And then we started, OK, so we have, at least now we have some measure of sanity. We can, again, release at a reasonable cadence. Let's start the work on breaking this code base up and cleaning up all of the things in there. And that eventually led to a decision to migrate from Ant to Gradle. And that's what we're working on right now, to migrate this very large code base to Gradle. And then at the same time, we said, OK, well, we don't want new projects that are starting up to have to go into this insanity. We want to have a framework around doing distributed and isolated code development. And so we created this tool set and process that's called multi-product. In a traditional software development methodology, especially prior to kind of the CI, continuous delivery, agile revolution, you would do what we did in network. You would have one well-established technology stack, and you must use that. Like, if you're starting a new project, you must write it in Java and put it in network. And you achieve simplicity from the fact that everything looks the same. And then to adopt a new technology, typically what happens, some out-of-the-box group or person or engineer out there was either hired or he didn't know that this is not what you did. So he thought out of the box and he said, oh, maybe I should go take a look at Scala, or maybe I should go take a look at this other thing and pull it into the organization. And then I'm going to build a bunch of demonstration or code, and I'm going to present it to management and say, see, this is obviously a better way of doing it. And they would say, yes, this is blessed. You have the resources and money to bring this into our company and change everything. And using that top-down management must approve methodology, you could slow down the rate of integration because that's very expensive. So LinkedIn has a stated goal of basically, we don't ever want to be in the box. We don't ever want to set any limits to the technology that we're using. It really is, our engineering management has said this is one of our top goals, is that we want to be the world's largest startup. So if you ever find yourself, or if anybody's telling you in your job, oh, that's good out-of-the-box thinking, or you need to think out of the box, you should ask them, why are we in the box in the first place? Why have we created these boundaries around us and said, we cannot do this? Because fundamentally, here in Silicon Valley, you don't need to do that. You can have, and I'll talk about this in a second, you can have constructive chaos. Chaos does not have to be destructive. So we really encourage technical experimentation and diversity. We encourage people to go out there, to go to conferences like this, to pull in tools like Gradle or other frameworks, new programming languages, and say, I don't know whether this is going to work out or not. I don't know whether this is going to be the next Java or not. But I'd like to try it. I'd like to build some stuff with it. And let's see how it goes. And we're finding ourselves constantly hitting limits. And we go out, we'll try our very hardest to find processes or software to solve our problems, and we'll fail. And we'll just say, OK, well, then we'll just build it. And then the other thing is we want to be on this forefront of continuous delivery, continuous integration. And so we want to move faster. I fundamentally believe that this incremental cycle that we can get to, where you're deploying all the time, actually leads to much better code quality, stability, a good way of moving forward. Because when you're deploying at, say, every 2 weeks or every 6 weeks or every 18 months, like I was in the previous job, you get these huge, huge changes every time you deploy. The ratio of successful deployments to failed deployments is huge, or is small, sorry, because you're always deploying such huge sets that you have some failure. And it's hard to get back to a good state, and it's hard to differentiate good changes from bad changes. But when you're deploying all the time, first of all, you change the culture of your engineers. So your engineers don't think about release points or anything like that. I just make some small incremental change. It's cheap to ship it. Let's ship it and see how it does. You can tweak, you can fiddle with things a lot better. And then you can automate this process to remove the human from the equation. So you want to get to the point where there's so much trust in the certification and validation of your system that there's no human intervention needed. Or only when things go horribly wrong does a human being have to step in and run some command or click some button. And as I mentioned, at LinkedIn, we continuously find ourselves with the point where we want more control, or whatever we need isn't available. So we're going to have to go and build it. And so we build a lot of things that we try to contribute back to the open source world that are really pushing the boundaries of what we can do in this space. So is there such a thing as constructive chaos? I think management science theory at this point argues very heavily for it. I would argue very heavily for it. I also argue very heavily that there is such a thing as destructive chaos. And I think at LinkedIn we have examples of that we have seen very clearly. So the whole concept of multi-product is architected around defining constructive chaos. So we want to take this top-down control of the engineering management, the technical leadership saying, these things make sense for us to do. with the engineers being, well, this is cool new technology. Let me try it out. Let me see how things go. So we want to define the boundary or a good middle way between those two things. So multi-product is a tool set that is architected for a heterogeneous world of technology. So from the very get-go, we said we don't want to be limited by build system, version control, or any kind of programming or technology stack. We will support any of those combinations. And I know Hans isn't here, is he? Okay, good. So, Hans would probably, yeah, we do support all the build systems besides Gradle. Don't tell Hans though, Stefan, okay? And then basically what we do is we abstract out some common tasks. We said, what are the tasks that we at LinkedIn feel are absolutely necessary? These are non-optional when you're building software. You need to build some artifact. You need to test the artifact. Yes, that is a non-optional piece. This is where the boundary between constructive and destructive chaos comes in, right? Destructive chaos is, well, I'm just going to release stuff. Yeah, and then I'll hit it in production and it works. That's my testing. No, that's not acceptable. And then I have a release step, right? I don't deploy things from my development box. I release it, and then there's a deployment system that deploys it. So these kind of boundaries is where we really found we can add a lot of value from a tooling perspective if we define them. And then let's provide such a kick-ass default implementation, an example by using Gradle, that people would, instead of having to tell people you must use Gradle, they'd be like, how can I get this niceness, right? How can I migrate to your stuff so that I get this coolness? And that has been, it truly, I've worked in tools now for about 5 years and at different companies. And that has been a very successful way of getting a culture change through an engineering organization. So let's make it so good that they'll want to move instead of telling them they must move. It's worked out really well. So what are some of the key concepts? I mentioned that we have this concept of product. In the kind of traditional, in default Gradle, you do a lot of things on an artifact level, an IV coordinate level. You do your conflict resolution, you do your you declare dependency, all of these things at that artifact level. We want to take, if we did that, I don't know exactly how many artifacts we have. I'm going to guess it's on the order of 10,000 in our single dependency graph. So if we try to reason about a 10,000 node graph, I mean, for sure, so for a computer, reasoning about 10,000 nodes with, n edges, and each one of those edges representing a version and each one of the nodes representing an artifact, a computer could easily reason about that. 10,000 node graph today is not big. But there's no way that a human being can reason about a 10,000 node graph. No way. So we want to take this and we want to collect artifacts together into logical units, version those units with a single version, and then elevate all of these concepts to that version. And we want to take all of that stuff out of the build system and put it into our tooling that's build system agnostic. Then we use Ivy and custom version and build specifications to tie all of these different pieces of tooling together. So we pass some metadata around to say, this is the input from one thing and this is the output to another. Then we want to architect it so that the subsystems are pluggable. So we can plug in Gradle, we can plug in Ant, we can plug in SBT, we can plug in Make, etc. And we can, in the future, plug in hot new thing foo into the system. We want very, very tight processes around version management. I really believe that version management, now versions do not have to correspond to a specific versioning scheme or, binary versus source artifacts or something like that. It's just some way of declaring, at this point in time, this was the state of my code. So it could be, subversion revision number. It could be semantic versioning. It can be all kinds of crazy versioning scheme. But at least you have some scheme. Like it could even be like 1.0 milestone, something crazy like that, right? Which, by the way, I gave the Gradle guys a really hard time about that whole milestone business. So, but we're past that. It's all it's all from the past. And then for all of these things, no matter what the technology stack, it can be Java code, Ruby code, Hadoop workflows, static content. We want automated continuous delivery for free. We want to make it so easy that people just say, OK, I'm just going to ship it all the time. So there are three main subsystems: source control, build system, and deployment. For source control, we do only support Git and Subversion. That's just an organizational thing. If you want a source control system, then you need to run a server somewhere locally in your internet. And for us, those are the two that make sense at this point. Build systems, there are so many that we support that I could fill up the whole messy slide with just build systems. But I just put Gradle and SPT here because I figured that would get a couple of people's blood pressure up, and they'd wake up after lunch. And then on the deployment system, we have our own deployment system. We actually have two right now, but one that we're moving towards. We really want to separate out the deployment from the build systems. I know Gradle, Maven, et cetera, SPT even has good ways of doing deployment, but we want to do that. We want deployment to be a very specific first-class citizen. We really believe deployment is a very important piece of running an enterprise software stack. What was that? I don't know how much I can talk about this, so I will respectfully not answer your question. So what about this? I mentioned version management is so important to us. Why is that? So in the traditional way, you would ship a version, and then you'd be stuck supporting or maintaining that version for essentially till nobody was using it anymore. And you really wouldn't have a way of knowing that nobody was using it anymore. Or you just decided at some point in time, we will stop supporting this version. And you send out a newsletter. You hope people read it. You hope people migrate. And then you remove it from your servers, and then people come yell at you. At least that's what happened to me. So we really want to support graceful deprecation and upgrades. So we want to be able to say, there's a critical bug in this version. There's a critical security flaw in this version. Or I'm just really tired of supporting this version. Could you please use a newer one? And if you're talking about this, right, you have a fixed amount of resources in the development organization. If you're spending a lot of those resources in maintaining stuff, or telling people, yes, this bug was fixed in version so-and-so, can you please upgrade? That's not an efficient use of your resources. At the same time, we want the actual producers or owners of the code to be able to push new upgrades into their consumers. And we want to be able to reason about it. We always want to be able to answer the question, who uses what, both from who consumes me and who do I consume. And we want to have very tight, nice tooling around that gives us a lot of information and power to manage our code, to manage our ecosystem. So one thing we've been working on, and this is still not being completely pushed out, is the ability to push. So in version management, you have two different modes. You can push or you can pull. So producers can push their code changes or their new versions, or consumers can pull in new versions. So we have a tool that lets you push your code into your consumers at specific versions. And at the same time, we have a tool for project managers, product managers, etc., or just engineers to be able to say, on this date, everybody must be at least at this version or have picked up this thing. This is what we use when, for example, we find a critical bug or security flaw in the code. And we say, OK, by this version, everybody must be at least have picked up this bug fix. And so we have all kinds of tracking and nagging features and things like that that automatically is populated, and actually in this case mostly populated by Gradle, to let us know exactly what versions people are using in the different stages of deployment. So what about continuous delivery? So Stepan actually showed this morning too, where Gradle uses push or triggered on pushes, they start their pipeline. That's what we do too. So the last time a developer has to interface with the product is when they commit the code. That's it. At that point, everything is automated. Right now, we have, and this number changes so quickly that the slide is already out of date, but we publish around 10,000 artifacts for about 300 products every day. So we've really been able to change this from, I'm going to publish well, for network, it was 2 weeks. For these multi-products, when they first came up, it was whenever the user hit a button, which was a very different cadences. To now we publish all the time. And our goal was to get this below 20 minutes. So 20 minutes will get you to the point where in half an hour, you can go from code commit to production, to certification, through the entire pipeline. At that point, you can do it within a session, within a typical developer session. So the developer sits down on their machine, they change some code, they get it reviewed, they check it in, and it's deployed, and it's running. And all that happens within one session. Mostly today, we're in the 24-hour, 8 to 24-hour cycle for most of our code, where the developer will check in some code, and they'll be able to see it running. If they check it in the afternoon, they'll see it running in the morning. Where they check it in the morning, they'll see it running in the afternoon. That's where we are. And it completely changes the way developers think about deployment, about code. It makes it so much cheaper for them to iterate and do things. And we've just seen a huge uptick in the amount of changes that go on and incremental updates. Yeah?
How do you deal with changes that whose effects may not be known until like 24 hours later?
What would be an example of such a change?
Things that show up in high volumes during peak hours?
That goes back to how much trust do you have in your validation pipeline? So if you trust your validation pipeline that it's hitting scalability, that it's hitting performance tests, that it's capturing, monitoring things like memory leaks, memory usage, that it's, so we have tools that do relative comparisons. So they'll compare the version that's currently deployed versus the version you're trying to deploy. And we run all kinds of validations on it. If you trust that validation and you continuously improve that validation, then you're good. And that goes for kind of all types of errors. Yeah, Darius.
It might be worth mentioning that there are some services that really you cannot validate in a short period, and they basically get carried into production in limited batches. But you have to, as the owner of the service, you have to decide that, what kind of metrics you're interested in.
Yeah. Well, and I would say, but that's a specific, we're not there yet, right? That just means that there's some work we have to do as a company, as an organization, or in the tooling side to achieve the level of trust where all this is automated. Now, Yeah, I mean, there's a lot of complexity hidden behind here. Obviously, if you're rolling out a major structural upgrade to, say, your data storage layer, that's not going to go out. First of all, it's not going to go out without a fair amount of people actually watching, monitoring systems and the site and things like that. Also, it's in many cases, it's not going to go out in just be spread out. It's going to be doing some phased, very specific rollouts. But again, we want these very smart people that we pay a lot of money to be doing things like that. Not the things that are like, oh, I changed, the font on this page, or I fixed a typo on this page. We want to make those things really cheap and automated so that the very highly paid smart people can do the really difficult things. So one of our kind of key learnings, one of our mottos is we want to automate ourselves out of our current job so that we can go work on the things that are more challenging in the future. So we track the continuous delivery pipeline. We track it very, very closely. We have, this is a single commit. We track all of the stages of the pipeline. We track everything that's going on. This is a Subversion product. So we also support Git. This is Subversions. We have the revision number. We have the review number. We can audit any change in the system. We know everything about every change in the system. And so when there are things that go wrong, we have a post-mortem meeting. And we go through the entire process and we figure out where did the process fail, where did the tooling fail, and where can we improve. And this is the, now we have per product, we have many drill down metrics. This is the top level metric, which is the average, the mean and the median of when a developer checked in a commit to how long till that commit had been published. You can see we had some, it's actually interesting. So you can easily see when you've had bad days, when stuff went wrong. All right, so that's a little bit about how we do product development. So up till now I would say about somewhere between 80 to 85% of all of these multi-products use Gradle. That's not mandated, it's their choice, but I want to talk a little bit about how we do build automation with Gradle at LinkedIn. So first of all, it's important, I think, to mention why does LinkedIn use Gradle and not something like Ant or Maven. If you ask me, what is the one thing you want a build system to do really, really well, especially a Java or JVM build system? It would be the dependency resolution. Like if you gave me one thing, the most important thing, that would be it. And after having worked in this space now for a little while, I feel that Gradle's dependency resolution engine is the best out there. I can honestly say that. You need the flexibility. So I mentioned we have this very heterogeneous technology stack now. So you need the flexibility to write plugins. We need the flexibility to do things in a very custom way that's specific to us. The Gradle DSL has a really high learning curve. I mean, there are many of us that have worked in Gradle and Gradle plugins now for a long time, and we still really struggle with the Gradle DSL, but it is really powerful. So the last thing is that the visions between what we're trying to do, what I've just presented about what we're trying to do at LinkedIn, and what Gradle's trying to do is really, really aligned. We really want to push the boundaries of automation and continuous delivery. We want to be able to move faster than pretty much everyone else. So we have this set of LinkedIn Gradle plugins. Without these LinkedIn Gradle plugins, we wouldn't be able to do much. Nobody at LinkedIn interfaces with the standard Gradle. So we have a set of plugins that are wrappers around the Gradle built-in plugins. So we wrap pretty much, well, I think every built-in plugin that we use LinkedIn is wrapped with LinkedIn functionality. So you would never apply the Java plugin or something like that. You would apply the LI Java plugin. And then we have a bunch of custom artifact types. So we publish and consume database patches. We publish and consume static content, including JavaScript. We publish and consume Hadoop workflows, et cetera, et cetera. So these things are they're new. They're things that we see a lot of. And there are things that I hope that Gradle will pick up in the future. Like I hope Gradle will have, for example, native Hadoop support. I think that would be very important given the kind of big data revolution that's going on now. Then we create all of our tooling, all of these plugins are integrated so they create metadata for other tooling to consume. So you can also create this if you have a different build system from Gradle, you can also create this metadata. We have tooling to do it for you, but you need to do the glue code to have the build system call that tooling and things like that. If you use Gradle, it's nicely integrated. It just pops out for any type of artifact. And then as I mentioned earlier, we want to take a lot of these concepts like dependency management and elevate them to a product level. So Stepan has actually helped us write a bunch of tooling that takes, for example, does versioning on a set or on a product level. So it knows that these artifacts are part of the same product. So therefore, they must use the same version, or they must be versioned the same. And what that allows us to do is it allows us to use Gradle to fuel a lot of interesting tooling, a lot of LinkedIn-specific tooling. So we can build a UI, and actually Thomas over here is an intern working in our group this summer. It is radically refactoring this right now. But we can build UIs and we can start reasoning and we can build services that have these graphs, these dependency graphs in them. So that we can answer questions like, who uses me? Who do I use? Who is using this version that has this critical bug? Who is deployed with this version that has this critical bug, et cetera. So we can answer a lot of these questions that either developers or the operations team have. And then we can do things like the version management I talked about. So I don't know how clear this is, but we actually built into the Gradle plugins as a non-optional task. You run this task, and it will validate that you are using up-to-date dependencies, that your dependencies have not been end-of-lifed, and try to give you some nice messages about what you need to do if you are using end-of-life dependencies. So I mentioned we like to build things for ourselves. There is the Gradle wrapper, and we decided not to use that. So we built our own Gradle wrapper called LI Gradle, and this is the entry point for all LinkedIn Gradle usage. So nobody uses Gradle or the Gradle wrapper directly. The Gradle wrapper, or our Gradle wrapper, sorry, LI Gradle, it does the same thing as the Gradle wrapper. It provisions Gradle and the plugins. So it allows you to say, I'm using this version of Gradle, and I'm using this version of the plugin. So the plugins are also versioned. And that allows us, we have these 300 different products, and they can each define the version of Gradle and the version of the plugins that they use. And they can have their own unique combination. And we can support all that provisioning. It also lets us do the same thing the Gradle wrapper does, which we don't need to muck with the people's Linux or Mac images or anything like that. It just automatically comes. The other thing it allows us to do is we want the same capability that we provide for our products for our build infrastructure. So we want to be able to end-of-life Gradle versions and end-of-life Gradle plugin versions, and say, OK, we're done with these. Everybody should be migrated off. The last thing, which is a pretty important thing to us, is we want to be able to track how this is used across the organization. So every run of LI Gradle or every run of Gradle sends a little packet to a usage metrics server that gives some basic information about that run. Yeah, that's a little bit Big Brotherish. No, we don't do any steps to anonymize this data or anything. So I know exactly when people come in the morning and when people leave and what they're doing. But that's one of the benefits of working inside a company, I guess. It's there are no secrets. Yeah, well, I guess given the whole NSA thing recently, it's I guess it doesn't stop there. But that usage data allows us to do two very important things. From a customer support perspective, it allows us to detect when things are going wrong before people tell us. And that's pretty important because people, depending on culture, some people have a really hard time speaking up and saying hey, this doesn't make sense to me. Is this broken? What's going on? And then, of course, you have the flip side of the coin, which are the people who, anything breaks and they're oh, it's broken, doesn't work. But it allows us to run some data mining and analytics on these things and say, what are some common usage patterns where people are not doing the right things? What are some common patterns of things that are going wrong? It also allows us to answer the question how many people are using this? How many times a day is it run, etc. So we have all of those metrics. I think I have that here somewhere. Yeah, so each workday at LinkedIn, there are about 5,000 Gradle executions. And there are about 10,000 execution of the multi-product tool. So I don't know how that stacks or if anybody even is tracking that kind of stuff. But that gives us some interesting ideas about, and we know how many unique users there are. That gives us.
Invocations or manual user entered invocations, or those are automated invocations also?
Also automatic invocations, yeah. We do have we do capture the username, so we know what are automatic and what are manual. So we have that information as well. Yeah. Okay, so I want to take right now. One of the big subjects of conversation at LinkedIn has been, what do we do in terms of source versus binary dependencies? So source dependencies or source level dependencies gives you a lot of flexibility in development. You can change anything, recompile it. If you're talking static content or JRebel or something like that, you can or even the Gradle daemon, you can easily get all those updates while you're working. So we decided to put that boundary at the product level. So inside a product, everything can depend. It's all source level dependencies, and it's all built at the time you build the product. And then when you have binary dependencies, you can use Artifactory, Maven Central, Nexus, Sonatype, etc., to actually offer stability and speed up performance increases. So we decided to put that boundary between products. So every time you declare dependency from one product to another, from one product to an external, some external source, that's binary. I'm not sure that's the right thing. Honestly, we're still debating it. We probably will blur those lines where we decide to, okay, by default, inter-product dependencies are binary, but you can flip some switch in our tooling, and you can pull down that source and start working on that source as if it were part of your product. So I would say that so far, at least, I haven't seen a right answer to this question, but I have seen plenty of wrong answers, for sure. For example, building everything at an organization like LinkedIn from source, that's just, it won't scale. It won't work. Using binary dependencies everywhere, that's just going to lead your developers to tear their hair out. So somewhere in that middle, I would love for someone to write a really good paper. Maybe Gradleware can do this. Write a super good white paper on source versus binary dependencies. I think this is one of the areas where after so long of having Java code and jars, etc., we're still struggling with a very basic concept. And you go to n different people at LinkedIn, you will get n different answers to how this should be resolved. So anyway, I thought this was pretty.
Are any of your LinkedIn people from Google?
Absolutely, yeah.
Advocating building source?
Yeah, so Kevin Scott, our senior VP of engineering, the head of engineering at LinkedIn, has actually been he's comes from Google twice. So he was at Google as developer number like 30 or something like that with a PhD out of Stanford. Made a bunch of money, went and started a company called AdMob, which does mobile advertising, which was bought by Google. So then he was back at Google, I think as a director or VP or something like that. And then he came. So he said he's one of the few people who've had the pleasure of leaving Google twice. But yeah. So we have a bunch of people from Google. We have a bunch of people from Yahoo. We have a bunch of people from Ariba. So there's all these different ways of doing things. Like Ariba, for example, they did everything from source. So they generated a manifest of all of the things that in the dependency graph, which is, I mean, we do that too. And then they would check all those things out at source, but they still version them, right? So source versus binary does not mean you can't have versions or use some kind of way to lock down APIs. So yeah, I mean, that's the other way of doing it, right? So now, whether it's physically located in one repository and you just decide to build pieces of it, or whether it's multiple repositories, that's also kind of equivalent, right? If you take the Ariba approach and you know exactly what to check out at what versions, that's almost the same as just putting it in one place. So there's so many different ways to solve this. And I think that there isn't a single best way to do it. I'd love to have someone write a white paper that said, these are the different ways, these are the pros and cons, here are some use case or examples of where each one works. So I mentioned we had this huge repository of source code that was relatively homogeneous. And after a while, we decided that the time had come to kill our custom Ant framework, which had turned into a huge monstrosity of custom stuff, basically. There's nothing wrong with Ant. There's nothing wrong with XML as to declare build dependencies. But there's something very, very wrong about what this thing morphed into over time. I mean, that's for sure. So we have about 3,600 build files to migrate over to Gradle. Status right now, as of today, I think we're at about 2,500 of them. We have unit tests, integration tests, and databases left to port over. There are 300 developers who don't know what Gradle is at all. I mean, literally, they do not know that this thing exists, let alone what a task is or how do I run things. And some of them are very angry that their Ant foo, which they have built, spent years building up, is now going to be useless. And the reason we want to do this is, now there are some very intrinsic reasons, like we want to restore some sanity back to this thing. But really, we've hit the performance limit. Now this is something I didn't believe in until I actually did the proof of concept. I'll talk about that. I did not believe that Gradle could do this faster than Ant can. But that turns out to be true. So we have set 2 performance targets. We want a 2x speed up for clean builds and 5x speed up for incremental builds. As of now, it looks like we're definitely going to hit the clean build. And we'll see what magic Stepan can pull out in the next 5 or 6 weeks to see if we hit the incremental speed up target as well. I'm using the nightly. Yeah. There's nothing besides the nightly that even remotely works on this, and I'll talk about that in a second. Well, up till now. Up till now, yeah. We cannot. 1.7 is not sufficient. We cannot go live with 1.7. It just.
Maybe clarify that we're not using the nightly for everything.
Oh yeah. Yeah. So yeah. No, the production code, everything is still using the Ant framework. So we have not gone live yet. Yeah. Yeah.
No, I mean we're also not using nightly builds for the multi-products.
Correct. Yes. Only for this specific product are we using the nightly. Yeah.
Experimental,
Yeah.
out of control.
Yeah.
Do you envision going to a version Gradle?
Yeah, I think once 1.7 is out, we may be able to use a real released version. With 1.8 we're planning on rolling out live with 1.8. At that point, we will need a real version. We can't go live on the nightly. Yeah. So we did a proof of concept, and Borat, yes, is giving the thumbs up. So we migrated about a third of this as a proof of concept. Obviously, we scripted the migration. We did not do it by hand. Although, that's always a good intern project, right? And really what we want to take a look at was, of course, this code is architected internally inside the product. It has some boundaries of how the code is organized. And so we really thought that the only way this would work is if we take each module and we segment the build at that point. We declare the dependencies, we declare the tasks, and then we kind of fake a binary dependencies between these segments. But we actually got to the point where we thought, or we were pretty confident that the scale is feasible in Gradle. Now, I should mention that for various reasons, every LinkedIn developer has a 12-core, 64 gigabyte memory machine with a 15K SAS hard drive under their desks. That's not specifically related to this project, but it actually is an artifact of that's what it took to deploy this product locally. So we have some, when I say it's feasible, the scale is feasible, it doesn't mean you can, do it on your laptop or anything. It requires very specific hardware. But we thought that it was easier to migrate the entire thing into a single multi-project build than it would be to actually split it apart at that point. And that's, if we funded some work in the Gradle core, we could actually get there. So that's what we decided to do.
So you're going to have one repository with 11
Yeah, 33,500 folders, yeah. So what have we built so far, and what are we hoping we can build? So the first thing, which you may have noticed, I can't remember, 1.3, 1.4 or something like that, configuration on demand came out. That is a super cool feature that I really hope will be the default very soon. It basically, instead of configuring the entire project every time you run a task, it does configuration on demand. So it's a smart incremental configuration option in the Gradle core. We took a lot of the cache logic and the parallel logic and refactored it. Or rather, should I say, Stepan took a lot of the cache and parallel logic and refactored it. If you look, at least for us right now, if you look at 1.7 versus, say, 1.3, 1.2, I mean, it's night and day how this thing runs, especially if you use parallel project execution. And then right now, we're taking a look at, can we do configuration in parallel? So can we have multiple threads doing configuration? Can the daemon do a lot more in the background in terms of storing and caching, and also in terms of actually doing work? So I think those are features that I really want Gradle to do in the future a lot better, where it's the daemon is a smart execution engine sitting in the background. And so we'll see how much of this stuff we get done. But we already made good improvements. So this BLD shared is the name we use for the old Ant framework. This is a very large war that we build. So to build it with BLD shared takes about 5 minutes. Building it with Gradle 1.4 took about 10.5 minutes, and building it with 1.7 takes about 3 minutes. So These are speedups that should be applicable most across the board, all around for Gradle. Of course, this requires configuration on demand and parallel. Those are absolutely required features. So, but we got to about 1,300 modules in our migration effort, and yeah, it didn't go so much further than that. I think actually with our 2,500 modules, we're pretty much exhausting the 64 gigabytes of memory that we have on our boxes. So there's certainly something going on in the Gradle daemon that we need to figure out what to do with. One thing is just how much memory does it use when you build the entire 2,500 or 3,600 project build. The other thing is that the memory continuously grows. So as you're doing their development, the daemon just sucks up more and more memory until it GCs and then sits there for 90 seconds or so and then comes back, and it gets very stuttery after a while. So we know we still have work to do on scalability and performance in Gradle core itself to make this work. So is there anybody who has a Gradle build that even remotely the scale, say like over 1,000 projects?
Not at once.
Yeah, that's it.
My purpose is to split it out so that it's all
Yeah. Remember, I said in the beginning, if you're looking for ways, if you're looking for best practices,
Yeah, we prefer not to.
yeah, we would really prefer not to do. And the goal is to break the. I mean, actually, it has already been broken apart quite a bit from where it was, but the goal is to break it apart a lot more. So this is going to take about a year. In Q1 of this year, we did some proof of concept and prep work. That all went well. Right now, as I said, we're finishing up the implementation. We likely won't be done by the end of June, which will be the end of Q2. This will fall a little bit into Q3. I think 1.8, if we just follow the 6-week cycle, 1.8 will probably be end of July, early August, which means probably middle of August. So that's when we can really exit this phase and then roll it out and clean up all the stuff that we can clean up, and then we'll be done. So that's the goal. So now I want to take a quick peek at the future. So what are some of the Gradle features that we're going to need and that we're looking at either the Gradle team building or us funding and then the Gradle team building? We want to go faster. We always want to go faster. We know we need to go faster in order to get this network migration going, but we need to understand how to use the daemon effectively, both in development and CI. I think that's one of the things we're kind of just skimping along now with, yeah, we always start the daemon, we leave it running, but it expires after a while. And how does it make sense to use it in our CI systems? So we have many different CI systems. What are the settings that it should run with? Where should it run, etc. So we really need to understand and then make sure that we have the flexibility that we need in the daemon. The daemon is absolutely key, I think, to making this go in general, to making the Gradle ecosystem work. I think it's one of the real differentiating factors for Gradle as a system. The other thing is right now we have, in incubating mode in Gradle, you have parallel project execution. That means different projects in your multi-project build can run in parallel threads. But we also need the ability to run intra-project parallel execution. So be able to parallelize tasks within a given project. If we don't have that, we're going to have to do hacky things like split, create dummy projects that their entire purpose is just to run a task because it can then be parallelized with another task. I think you always will find that specific projects and specific tasks within specific projects, like assembling the war, assembling very large artifacts is going to dominate your build time. So in those projects, we need the ability to say, well, yeah, I know you're going to be spending 30 seconds assembling this very large war, but by the way, you can run these other things, the tasks that come from the same project in parallel. Let's get those out of the way. So I think that the daemon, which is not incubating, it's a first-class feature. I think parallel project execution needs to be put into it needs to come out of incubating and become a very first-class citizen. And it needs to really, from my perspective, it should be the default. Like, there should be no choice, or there should be no question with today's computer architecture whether you want to do things in parallel. That should just happen. And then I talked about the heap usage. I'm sure we will hit other limits too. As we go up to 3,600 projects and roll it out to 1,000 people, they will be telling us, hey, this doesn't work. This doesn't do what I need it to do. We really want to move away from having people tethered to their desktops and onto thin devices. So for sure laptops, but also even thinner devices like kind of cloud machines, iPads, whatnot, right? We want people to start feeling that they're enabled to leave their desks and they can just do development. They can do development in any language, in any form, anywhere. And that also comes into this ease of use category. This is something where, IDE integration for sure is something that always, the more we can do, it's probably a net win. We invest some time in making this easier for people, to making this better for people. For example, the ability to control the daemon, to control execution, to run tests, to see test results, code coverage. We're mentioning, check style, find bugs, static analysis. All these things should just be integrated so people just stay in their comfort zone, in their IDE, and they get all the information they want. So I think there's a lot more we can do here. The other thing is, one thing I didn't mention is just the general responsiveness. So when you're looking to roll out Gradle to somebody who's been an Ant user, for example, the first thing they always say is like, why does it just stop and say loading? Whether it's a small project, so it's 5 seconds, or a large project like the network migration, it's 30 seconds. It's like, what is it doing during that? Like, I'm used to just, you say Ant something and off it goes, right? So don't discount those things as silly. They are silly. That doesn't mean we as tooling developers can ignore them. So I think I'm really excited about using the daemon to solve that problem, to basically be able to say, Gradle tasks or Gradle build or something like that. And it just goes. It just does something. It doesn't have that spin up time or configuration time. I think that will help us a lot when we are trying to sell this out. What are some of the things for us on our side that we're looking to work on? I think a lot more analytics. So we spent the last year and a half gathering data about different things, and we have more and more and more data coming in. I think we can really start taking a look at that data, and we're pretty good at doing data analytics at LinkedIn. So maybe we can apply some analytics to that data and really start reasoning about how people work and where these productivity sinks are. We know that there are huge productivity gains to be had at LinkedIn, right? And if you multiply that by 1,000 people, that's a lot of time that's wasted doing things. I don't know exactly what I know some of them. I don't know exactly what those are related to Gradle, but I really want to figure it out and resolve that. And I'm really excited about Gradle 2.0 being a milestone where we can really start tackling some of these things. I think for us, we need to integrate better with this verification suite. Baron over here is actually going to be working on that. I think that's absolutely key. Because up till now, we've been focused on enforcement and figuring out when things go wrong. But the best thing would be if we don't ever get there. We don't see the failure. We give people enough information up front to where they don't even, check in the failure or try to check in the failure. And that also goes to automation and integration. I think that where we want to go with tooling and with Gradle is we want to integrate. We want all of these pieces to fit together. Today, it feels kind of disparate. You have to go to the shell and type, a light Gradle build. You have to do all of these different things. It should all just be integrated in together as one suite. And that also goes to the ease of use. That's something where we really need to get better. So I want to mention quickly, I think that one of the future directions that I see for Gradle that I'm super excited about is the ability to do truly distributed builds. So we have a huge amount of computing resources available to us. And with parallel execution, we can take pretty good advantage of a single machine's resources. But if we had a way of distributing the build, for example, if we had a way of distributing the network build, going from, say, 20 minutes to 10 minutes to 1 minute. I mean, there's so much that can be had there just by splitting it up. It's a huge problem. It's very difficult from a technical perspective to make it really fly, to be able to do provisioning of the code, to have a centralized storage node, computing nodes. For example, Hadoop, right? You spend 20 minutes just provisioning everything and getting everything up and running. If Gradle can do this really, really well, that's just a home run. So if we can figure out how to provision these machines, share the code between them, share the artifacts that are built between the nodes, and make all that go without suffering a large performance hit from the provisioning itself and artifact sharing. That would really resolve a lot of our problems. At that point, I think we would just move to always build from source, essentially. And we would just have a build farm. I mean, the vision would be we just put a bunch of servers, and we're talking hundreds of thousands of servers in the build farm. And we just send it jobs, and it just cranks through these things like you wouldn't believe. That, I think, would be a really cool vision for the way Gradle works. And that's what I had. Any questions? Yeah?
Thousands of modules and projects. At what point do you decide that some of them may be redundant?
Well, that's really hard. It's really hard to do from a kind of static analysis or automated perspective, because obviously we can easily detect if a project or a module is not used by anyone, but detecting that it performs some duplicate functionality from a different module in most cases requires some kind of human intervention, which requires the organization to say, looking at those things, investing resources in those things is needed at this point in time. So I think that automating it, I think we've done all we can, and it's now up to an organizational or priorities level to figure out what we should do next. One of the benefits we get from moving to Gradle is now splitting things, migrating things out of this code base is much easier because it's just a copy. Instead of having to translate the build logic from one system to another, it's now all integrated, so you could just copy it out. But I'm hoping, and I'm sure some of my colleagues share this hope, that we will actually focus some resources on tackling this code base at some point. Yeah?
Can you give us a little bit insight about the configuration on demand? Do you mean actually dynamically generate that configuration whenever the build started? Like I only want to build part of the product. Is that the what I'm talking about, or you are talking about something else?
Well, so by default, if you don't use configuration on demand, anytime you run a Gradle command in your multi-project build, it will configure the entire multi-project build. What configuration on demand lets you do is if you run, it looks at the specific command or task that you're running, and it will configure the parts of the task graph and dependency graph that you are requiring for that task and that task only. So when you have a very large multi-project build where you only hit a small piece of it, for example, during development, it becomes an absolutely critical feature to have. To give you an idea, right now with 2,500 modules, the configuration time of the network multi-project build is around between 90 seconds and 2 minutes. So if you're going to your little module and you're saying, Gradle clean, and you're waiting for 2 minutes for Gradle to configure the entire project, that doesn't make sense. So I think it's an absolute necessary feature to have in order for this to work. Yeah?
What are some examples of things you do in your customized versions of the standard Gradle plugins, like Java or something like that? You gave one example where you're sort of enforcing dependency checks, things like that. What else do you do?
Well, certainly, so we're elevating a lot of these dependency rules and version management and things to the product level. So we're making sure that, if you apply the LI Java plugin, we perform these rules. We add a lot of custom tasks that come from our plugins. We output the metadata, so we make sure that the artifacts we create and the associated metadata are there in order to tie the Gradle tooling in with the other pieces of our tooling. We don't do a lot in, say, the LI Java plugin. That's a fairly thin wrapper. There are others where we do much more convention-based things. Now, we do change conventions, so we may have a different convention for where the source goes, for where the built artifacts goes, all these different things. Yeah.
Is that just done for historical reasons, or you?
No, we as part of this, we were able to completely define all of these things. So there's no legacy or reasons or historical reasons behind this. We literally went through and said these are the things we feel. This is the way we think it should be done when you have when you elevate from the artifact level onto the product level. So we do everything at the product level, not at the artifact level. Yeah. So all of the build artifacts go back to the root project, etc. Yeah. And the root project is just the meta project. It doesn't have its own inputs and outputs. The only thing it does is define some of these configurations. Yeah.
So what does it look like to add products and add artifacts under products and take away products from the developer's perspective?
So we add products like crazy. When the beginning of 2012, we had 18 products, and today we have 315 or something like that. So the creation and deletion are fully automated. You run a specific set of tooling and commands to do that. Again, every version has a set of artifacts, but between versions, that list is dynamic. So you go to your product, you add a new module or directory, you add a new build.gradle file, and you just build. So it's all integrated and automated. We don't require very little we require our application developers to know about Gradle or multi-project builds or configurations or settings or anything like that. It's a very, very thin layer on top of it all. And we push an enormous amount, pretty much, so much gets pushed into conventions in our plugins. Because I think that would be the biggest barrier to entry for us.
So when a developer is working on something, are they checking out at from your source code repository at the product level, at the artifact level, and mixed?
Always at the product level. They do everything at the product. They don't know anything about artifacts at all. Well, that's not completely true. The one place where they have to specify is in the actual build.gradle file. They have to, because that's the way Gradle is architected, as you say. I declare a dependency on this specific artifact. That's something we would like to automate as well in the future, so you don't have to do that. But for now, you have to do that. Yeah?
How do you share your in-house frameworks across products, so you're not reinventing the wheel for each product line?
So we have, our products are in a hierarchy. They're in a DAG. And we take very great care to make sure it's a DAG and no cycles. So the lower lying leaf nodes are all library and frameworks. So we go from libraries up to the framework level, up to the deployable level. So you can kind of think of it like deployable frameworks, libraries. And then anybody at any given point in time can declare a dependency to a framework or a library. Yeah. But a framework cannot, a library cannot declare dependency on a framework, and a framework cannot declare dependency on a deployable. Yeah. Yeah.
Question. What do you do with check-ins or pushes which fail to pass an integration test in a pipe? So
They get reverted.
You just roll back.
Yep.
What if?
Well, so that's an interesting question actually. So so I know, for example, Git has the ability to actually go back in time, but we felt, and we had so many problems with that. So what we did instead is we revert by going forward. So we'll uncommit or unpush the changes, but we're still moving forward in revision number or time, if that makes sense. So if you push something that fails, we will push a commit that does undo on your changes.
So if meanwhile, like 5 other developers push something in, so that may create quite a complicated situation to solve.
Yes, it would if you didn't have this CI pipeline run on each commit or each push.
Okay, so it's full, but does it mean the developer cannot push until this?
No, they can.
So the repository is kind of locked.
No, they can run many in parallel. But if you push, we will start the pipeline on your push. We'll know if anything failed on that pipeline, it was due to your commit. If somebody else starts another or does a push while your pipeline is running, then we'll know that that push was related to their commit.
No, but if somebody has made changes based on his commit.
That's what I'm saying. We isolate them.
But what happens in the end what if there is a conflict?
Well, we have very good tooling to make sure that we can undo your commit and your commit only. There are some very rare occasions where it will fail. And at that point, we have a system set up to notify the developers that we don't know what happened. Like, there's some very specific where you have SVN externals or Git submodules and stuff like that where it gets kind of hairy. And at that point, we have a system, automated system, that lets developers know that your commit failed, but we were unable to roll it back. Please do so manually. And they get continuous levels of escalations until they do that. And it's a pretty big deal. So we've elevated that to a cultural level, basically. If you do that and you don't take care of your stuff, I think Stepan Content talked about it earlier today. It's like at that point you need a culture around like ownership that I push something bad, this is my responsibility to fix it. But again, I mean, we were talking about it earlier. We don't want our developers to worry about any of that, so we try to automate the most of it we can. Yeah.
It turns out that if you're moving through the pipeline fast, it's much less of a problem.
Yeah.
Because there's like it's relative to latency. If the time taken between when the commit is enters the pipeline and when it fully exits the pipeline in the form of a deployable product, if that's short, the chances that it conflicts with somebody else's commit in the same pipeline at the same time go down. So we, in the extreme case, a human gets involved,
Yeah.
but the extreme case happens less often than we expect, actually.
Yeah. Yeah, and I mean, it's very, very product dependent, but the average for a successful commit is on the order of 5 minutes. The average overall is around 20 to 25 minutes, and that's because, you know, when something fails, it's marked as failed until somebody checks in something that does pass, even though it is rolled back. Because what we measure is the time between the push and the publish. Yeah.
So do you have like a wide pipeline, multiple things running in parallel?
We have a super wide pipeline, yeah. So to publish we publish somewhere between 10 and 15,000 artifacts a day. The pipeline is around 250 to 300 wide. I think we run on average, something like 5,000 jobs a day or something like it. It's pretty large, yeah. And during the middle of the day, so there's interesting metrics as goes, you know, around 10 a.m. the graph starts going up and there's a bubble, you know, around like 11 a.m. And then at 12 it goes to like 0 and it stays there till 1 p.m., 1:30. And then everybody checks in their work for the day and there's a huge spike there. So it's very spiky. For most of the day, this machinery, this huge honking machinery just sits idle. And then, as I said, between like 2 o'clock and 4 o'clock and 9:30 or 10 a.m. and 11 a.m., they're huge spikes. Yeah. Anything else? Yeah?
You want to talk about semantic versioning and how we use dependency language?
Yeah, I think, as I mentioned, I think that's more, I mean, it's very detailed. We do use semantic versioning. I think it's important to have some way to denote backwards incompatible changes. But I think the versioning scheme is actually, like, you can pick any versioning scheme you want as long as your versioning scheme makes sense. But I do think semantic versioning is a very good versioning scheme if you need that. All right, thanks everyone.